Question 1. Without using a calculator, evaluate. In this question, you're going to begin with numerator. So the numerator is negative 13 plus 5 minus 70 divided by 5. We shall follow this order to operate BODMAS, and according to this order, we're going to start with division. Division should come first. So we work out 70 divided by 5. So this will give 70 divided by 5, you get 14. Now we have addition and subtraction. Addition should come first. So work out negative 13 plus 5 will give you negative 8. Then subtract 14. Negative 8 subtract 14 will give negative 22. So that is the numerator. Let's go to the denominator. The numerator, the same. We have multiplication, we have subtraction, we have division. According to this law of BODMAS, the first operation should be division. So we have 9 subtract 14 multiplied by negative 3 divided by 21 will give negative 1 over 7. Now we have subtraction and multiplication. Multiplication should come first, and here we shall get 9 subtract. When you multiply 14 times negative 1 over 7, this one you get by 7 1 by 7 2. So this will give negative 2. So that one will give negative 2. 9 subtract negative 2 will give, this will be 9 plus 2, and this will give 11. So now it is time to get the answer. The answer we got in the numerator, which is negative 22, divided by the answer we got in the denominator, which is 11. And when you divide these, you get negative 2 as the answer. Question 2. Simplify the expression. Now to simplify this, I will split the terms in the numerator and the denominator. And this is how I'm going to split it. For the numerator, 3a squared b raised to power negative 3. Let me split that to have 3 times a squared times b raised to power negative 3, like that. Then for the denominator, the same, 2 raised to power negative 1 times a raised to power negative 2 times b squared. To work out these, we are going to use a specific law of indices when you are dividing and when you're multiplying. Recall this law. Given a raised to power m divided by a raised to power n, this is when you're dividing and the bases are the same. You take the base is the same. So what you do, you take the powers and subtract them. So m minus n. So in this particular question, let me deal first with a and b. So look at a squared divided by, so we have a squared divided by a raised to power negative 2. The base is the same, so subtract the powers. So 2 subtract negative 2, and this one will give a raised to power 4. The next one is b. So we have b raised to power negative 3 divided by b squared. Again, we subtract the powers, the bases are the same. So this will be negative 3 minus 2, and this will be b raised to power negative 5. Once you're through with that, now I can take 3 and 2 raised to power negative 1. So 3 divided by 2 raised to power negative 1 is the same as, read it here, 2 raised to power negative 1 is the same as a half. So this is the same as half, like that. So this one will give 3 times 2 divided by 1. This one will give 6. Now we have, for a, we have solved, you got that. For b, we solved, you got that. For this one that we have the values, for 3 divided by 2 raised to power negative 1, we have that. So now let's go to the solution. So for 3 divided by 2 raised to power negative 1, we got 6. We multiply. For a squared divided by a raised to power negative 2, we got a raised to power 4. And then for b raised to power negative 3 divided by b squared, we got b raised to power negative 5. So therefore the solution will be 6a raised to power 4, b raised to power negative 5. Or you can write it like this: 6a raised to the power 4 divided by b raised to the power 5. Since b raised to the power negative 5 is the same as 1 over b raised to the power 5. Not that. So that is how you're supposed to solve that question. So these are the solutions. So this the solution, or can also be this. Question number 3. A triangle ABC is such that AB is equals to 11 centimeters, BC is equals to 8 centimeters, and angle ABC is equals to 53 degrees. Calculate the area of triangle, correct to 2 decimal places. Let me first sketch this triangle. So triangle ABC. Just a sketch. So A, B, C. So AB is 11 centimeters, BC is 8 centimeters, then angle ABC, this is the angle, 53 degrees. How do you get the area of this triangle? Just look at the measurements that you're given, and you notice you are given 2 sides and an included angle. So which specific formula are we supposed to use? You can use half base times height. It is not applicable here. You can use the hero's formula. Hero's formula can't be applied here since we are not having all the sides. We remain with this formula area. When you have 2 sides given and an included angle, use this formula: half AB sine theta, where AB are the 2 sides given and theta is the included angle. So just substitute this. So area is equals to a half times A. We let A to be 8 and B to be 11. Then sine of the angle, which is 53. So just use a calculator here. And you get, correct 2 decimal places, you get 35, you get 35.14 centimeters squared. Correct to 2 decimal places. Question 4. A cylindrical solid of radius 7 centimeters has a conical top of the same radius. The height of the cylindrical part of the solid is 17 centimeters. The conical top has a vertical height of 9 centimeters. Calculate the volume of the solid. Take pi to be 22/7. We begin by sketching. This is a cylindrical solid, so there is a cylindrical part. So let me sketch the cylindrical part. And then there is a conical top. Just a sketch. And you given that the radius of this cylinder is 7. So this is a 7 centimeters. And the height of the cylindrical part is 17 centimeters. So that height is 17. The conical top has a vertical height of 9. So this height here is 9. So having that, we require to get the volume of the solid. So we have 2 shapes here. We are going to start with the cylinder. So the volume of the cylinder is given by pi r squared height. So pi is 22/7. The radius of the cylinder is 7. So 7 times 7, that is 7 squared times the height, which is 17. So just use a calculator to work out these. And you'll get 2618 centimeters cubed. Then we go to the cone. Volume of the cone is given by a third in this formula, pi r squared height. So we have a third times pi, which is 22/7, times radius, 7 times 7 squared, times the height, which is 9. Again, use calculator to work out these. This will give 462 centimeters cubed. Now the total volume of the whole solid, that is the volume of the cylinder plus the volume of the cone, that is what is going to give the volume of the solid. So we simply take these, we add these. The volume of the cylinder is 2618 centimeters cubed plus 462 centimeters cubed. When you add these, get 3080 centimeters cubed, and that is the volume of the solid. Question number 5. 2 light bulbs are set to light after every 40 seconds and 60 seconds respectively. If they light exactly at the same time initially, calculate A, the time in minutes they will take to light together again, B, the number of times they would light together in the first half an hour. Let's go to part A. The time in minutes they will take to light together again. These bulbs are set to light after every 40 seconds and 60 seconds. So to get the time they will light again, we simply get the least common multiple of 40 seconds and 60 seconds. That will give us time in seconds that will take to light together again. So let's get the LCM of 40 seconds and 60 seconds. So now to get these, several ways of getting these. So let me start with 2. This will give 30 divided by 2, you get 10. 15 divided by 2, you get 5. This will be 15. Go to 3, it will be 5. This will be 5. Then 5, 1, 1. So this will give the LCM will be 2 cubed times 3 times 5. Multiply these. This will give 8 times 3, which is 24. 24 times 5 will give 120 seconds. So these bulbs are going to light again after 120 seconds, but you're required to give the time in minutes. So to convert seconds into minutes, we simply divide this one by 60, and we notice they will light again after 2 minutes. So that is how it's supposed to work out the first part. Part B, the number of times they would light together in the first half an hour. In the first half an hour. So in half an hour, that is 30 minutes. We're going to use minutes since we have already found in the first part that they are going to light again after 2 minutes. So how do we get the number of times? So for them to light once, they take 2 minutes. So what about in half an hour, which is 30 minutes? How many times will they light? So we take 30 multiplied by 1 divided by 2. You notice that this will give 15 times. They're going to light together again 15 times in 30 minutes, that is in half an hour. Question 6. Solve the equation cosine of 2 theta is equals to sine theta for theta should be greater than or equal to 0 radians, and also it should be less than or equal to pi radian over 4. Leave your answer in terms of pi radians. So in this question, we are going to use the complementary property in trigonometry. Just recall this. Recall that given cosine of angle A is equals to sine of angle B, then if you take angle A plus angle B, should add up to 90 degrees. So in this case, you have cosine of 2 theta is equals to sine of theta. So look at this. So when you take 2 theta plus theta, that one should add up to 90 degrees. And this will give 3 theta is equals to 90 degrees. And theta will be 30 degrees. But in this question, you're supposed to leave the answer in form of pi radians. So you know how to convert degrees to pi radians. Just recall this, that pi radian is equals to 180 degrees. So what about 30 degrees? So just cross multiply and you'll find that this one will be 30 divided by 180 pi radian, which will give 1/6 pi radian. That is equivalent to 30 degrees. So when you look at the range that you're given, pi radian divided by 4, we don't have any other angle that we can give. So therefore, theta is equals to 1/6 pi radian. Or you can write it as pi radian over 6. Question 7. Simplify and hence factorize the expression is given there. So we shall begin by expanding. So let us expand this part that is here. So we expand this part. So 5x minus 4y, 4x plus 5y. Let's expand this. How to expand it? So you take 5x multiply by 4x plus 5y. Then you take negative 4y, 4x plus 5y. 5x times 4x, this will give 20x squared plus 5x times 5y, get 25xy minus 4y times 4x, you get negative 16xy, then 4y times, we have 5y, this will give negative 20y squared. Like terms, so you have 20x squared, 25xy, subtract 16xy, this will give 9xy minus 20y squared. So that is the expansion, whatever I have indicated here. Then the whole of these you must subtract to have here 9xy. When you do that, there's something that you notice. We have 9xy, subtract 9xy, that will be eliminated to be 0. You're going to remain with 20x squared minus 20y squared. 20 is common, factor out 20, remain with x squared minus y squared. Remember this difference of two squares, recall this, that x squared minus y squared is equivalent to x plus y, difference of two squares, x minus y. Therefore, this will be 20 brackets. When you expand x squared minus y square, that is difference of two squares, you get x plus y, then x minus y, and this is the final solution. Question 8. From a point on top of a cliff 40-meter high, two boats A and B are observed due east. The angle of depression of boat A is 32 and that of boat B is 52 degrees. Determine the distance between the two boats, correct to two decimal places. It is very important to sketch these so that you can be able to solve it easily. So I'll begin by sketching. So from a point on top of a cliff 40-meter high, two boats A and B observed due east. So due east. Now the angle of depression of boat A. So let me start by drawing the cliff. Assuming that this is the cliff. So there's a cliff, and then this is the horizontal ground here. So the angle of depression of boat A is 32 degrees. The angle of depression, get it from the top. As you observe on top, as you look downwards, that is the angle of depression. There's a difference between the angle of elevation, the angle of depression. The angle of elevation is when you are down, somewhere on the lower side. You're elevating your eyes, you're looking upwards. Depression, you're looking downwards. So from the top here, assume this is how we indicate the angle. This is how we indicate. So I'll draw a line here. Sorry. So the angle of depression, this is A. This is the top of the cliff. So the angle of depression, we measure it like this. This is the angle. That angle is 32 degrees. That will automatically give us this angle that is here. Look at this line. This line is parallel to this, and this line is a transversal. So that 2 is alternate to this angle that is here. So this one will be 32 degrees. That will be the angle of elevation from now A to the top of the cliff. Then for B, the angle is 52. So 52 will be somewhere here. So 52 degrees. Now this will be 52. So from here, so this will be 52 degrees. And again, that angle is 52. This one is alternate. And this one also will be 52. It is 90 degrees. So the height of the cliff is 40. That is 40 meters. Now you're required to find the distance. This is B. So from the top of the cliff to B, the angle of depression is 52 degrees. Having that, right angle triangle here, is supposed to determine the distance between the two boats, correct to two decimal places. The distance between, so that is the distance B. So this is the distance that is required. So that is the distance. So how do you go about this? When you look at this diagram and this right angle triangle, you can use trigonometric ratios to get that distance. And the easier one, looking at the side that you're given, we can use tangent. There are two. I can let this length from here, indicate it. So there's this whole length here. You can let that length be be, let's say, y. And then there's this distance that is here. And let this distance be represented by x. Now using that, we can use tangent, considering this triangle that is here. Let's consider this triangle. So considering that triangle first, we can say tangent of 52 is equals to opposite side, which is 40, over adjacent. Adjacent is x. So this one will be able to give us x. So x will be given by 40 divided by tan of 52 degrees. Working out this one using a calculator, you get that 1.25 meters. You're giving the answers correct 2 decimal places. Then we have now the bigger triangle, with the base y. So we take this angle 32, so tan of 32 degrees is equals to, the opposite side is still 40, but now the adjacent is y. The whole of that length is y. So this one will be able to get y. We make y the subject, by multiplying both sides by y and then dividing by tan 32. So y will be given by 40 divided by tan 32 degrees. And this one, working out this using a calculator, you get 64.01 meters. Now we have these two lengths. So we have this side, which is 64.01, and then we have this one as 31.25. Now to get BA, the distance BA, we simply take the whole length, which is 64.01, then we subtract 31.25. We remain with that required length, which is BA. This one will give us 32.76 meters. As simple as that. Question 9. In the following figure, triangle ABC is a uniform cross-section of a solid ABCDEF. Given that BE is one of the edges of the solid, complete the sketch showing the hidden edges with broken lines. So for this question, you need to do it accurately, and therefore you'll need a ruler and a pair of compasses, as you can see. So this is how you're going to draw the remaining edges. So take the pair of compasses and you're going to first take the measurement BE. So let's take the measurement BE. So we take measurement BE, then that is the measurement BE. Then because on the other side, the opposite side, on this side you need the same measurement. So you stand at C with that measurement, and then you mark an arc there, that we are getting this edge that will be here, opposite BE. Then from there, with the same measurement, the same length, you stand at A, the pair of compasses, then you also mark another arc there, So by that you will have two measurements. Then from there you'll need BC. You can see you need this measurement here. You need to have this measurement from E, the side opposite. So we take measurement BC. So take measurement BC. So that is measurement BC. With that measurement, you stand at E, and cut that arc that you made. Cut that arc. It's okay. Then you need there's another measurement that you need. This measurement that is here. You need this measurement that is opposite AC. That measurement will be equivalent to AC. So take measurement. I take that length AC. So I'm taking AC. That is AC. Then stand at this point of intersection of these arcs, and cut that arc. That will give us the length that is opposite AC. So cut it like that. Let me see the other measurement that is missing. I think that is okay. You have measurement opposite AC. That one you've got it. Then the measurement that is opposite BC, you have it. So from there, take a ruler and join. You start joining these. So you start by joining that. That will be continuous line to not be hidden. Then also join this one as well. This one will also be continuous line to not be hidden. We'll start with the ones that are not hidden. The other one is here. So that one, we join that one as well, like that. Now we've done all the lengths that are not hidden. Let's go to the hidden ones, the one that you cannot see. We start with this one that is here, this one. So there's this one. This is the first one that will be hidden. So that one you're going to complete it using broken lines that will be hidden like that. Then the other one is this one. So that one. So this one will be broken as well. This one will be broken as well. So this one. So this is the next. So that one will be broken. And I think we've completed all the hidden broken lines. So the ones that are broken are the hidden ones. So we must label this one. That is the final thing we're going to do. So A, B, C, D, E, F. So this will be A, B, C. Then D will be there, E will be there, and F will be there. So you have completed the sketch, and you have shown all the hidden edges with broken lines. So that is how you're supposed to solve that. Question 10. A salesman sells storybooks and textbooks. The cost price of a storybook is 600 shillings, while that of a textbook is 900 shillings. The salesman is paid a commission of 10% on the cost of any book sold. One day, the salesman sold twice as many storybooks as textbooks. He earned a commission of 8,400. Determine the total number of storybooks sold. So we shall begin by, because we don't know the number of storybooks or textbooks that were sold, we can begin by letting the number of, let's say, textbooks be represented by X. And since we are given that the salesman sold twice as many storybooks as textbooks, so therefore the storybooks will therefore be 2x, twice as many storybooks as textbooks. So when the number of textbooks are X, storybooks will be 2x. That is the number. The cost price of a storybook, one storybook is 600 shilling. So at 600, and then for a textbook it is 900 shillings. The salesman is paid a commission of 10% on the cost of any book, 10%. So let's get the commission. This is how we get the commission. 10% of the cost of any book sold. Let's say one book, the commission on one book, and we're going to begin by the commission obtained by selling one textbook. One textbook goes for 900 shillings. So the commission of one textbook will be 10% of 900. That is one book. And how many books are there? The total number of textbooks, they are X. So you have to multiply by X to get the commission for all the books. So that expression, 10% of 900 times X, will give us the commission on all the textbooks. Then we add, because we are given that he earned a commission of 8,400, that means it is the commission of the storybooks and the text. So for the storybooks, it is still the same, 10% of one storybook, 600. That is a commission of one storybook, 10% of 600. And the number of storybooks sold are 2x. So now that will give us the commission for all the storybooks. And when you add these, when you get the total, this will give 8,400. So we work out this, 10%, same as 10 over 100, multiply by 900 times x, 900x, plus 10%, that is 10 over 100, times 600 times 2x, that will give 1200x, should give 8,400. So working out this one will give 90x, as this one will give 120x, is equivalent to 8,400 total commission. 90x plus 120x will give 210x is equals to 8,400. X, divide both sides by 210 to get the value of x. And this one will give x as 40. What was x? X was the number of textbooks. So the number of textbooks, therefore the textbooks are 40 because x is 40. Then storybooks are twice that, so this will be 2 times 40. That will give 80. And we've answered the question. Determine the number of storybooks. That will be 80 because just need to multiply by 2. X is 40, 2x will be 40 times 2. Question 11. The equation of a curve is given by y is equals to x squared. Using the trapezium rule with 4 strips, estimate the area enclosed by the curve. Y is equals to x squared. The lines x is equals to 1, x is equals to 5, and the x-axis. So we're given the limits from x is equals to 1, x is equals to 5. So what we need in order to use the trapezium rule, we need to know the height that you're going to use for each of the trapezia, each of those strips. What height are we going to use from x is equals to 1 all the way to x is equals to 5? And to do that, to get the height that you're going to use, we take the difference in the interval from x is equals to 1 to x is equals to 5. So we take 5 subtract 1 divided by the number of strips required. And this will give the height of 1. So meaning if we prepare a table of values from x is equals to 1 to x is equals to 5, you're going to use the height, the uniform height of 1. So let us prepare the table of values. So this is x, this is y. So from 1, the height is uniform, to 2, to 3, to 4, to 5. The interval of the height is 1. Then from there we can use the function to get the values of y. So when x is 1, what is y? We're using this function, y is equals to x squared. So in order to get the y, we simply need to square the x. So for y, when x is 1, 1 squared is 1. Then 2 squared here will be 4. 3 squared will be 9. 4 squared will be 16. 5 squared will be 25. So you can call this the first value of y to be y0. This is y1. This is y2. This is y3. This one is y4. We are using the trapezium rule. So this is the trapezium rule. Area using the trapezium rule is given by this formula. Half height, then the first height, that is y0, plus the last, which is y4, plus twice the middle or the middles from y1. You add, you get the sum of these, sum of the middles, y1 plus y2 plus y3. Those are the middles. So let us substitute them in this formula. So we have half times the height is 1, then y0 is 1 plus the last, which is 25, plus twice the middles are y1 is 4, y2 is 9, y3 is 16. That is equals to half times 1, this will get a half, then 1 plus 25 you get 26, plus we add these 4 plus 9, that is 13, 13 plus 16, that is 29, 29 times 2, that will give 58. Then we have half, multiply by, get the sum, 26 plus 58, you get 84. So half of 84 will give 42 square units. Question 12. Vectors A, B, and C are represented on the following grid. You can see them. So B is not clear now, so let me draw it so that you can see it. So that is B. Then the questions on the following grid represent the resultant vector A plus B, then B, the resultant vector A plus B plus C. So let's begin with A plus B, the first one. So in vectors, direction is very important, and just to write vector A in column vector showing the displacement both in the x and the y axis. So vector A, look at the direction. If you write this one in column form, the displacement horizontally, that is the x-axis, that is to the right. So beginning from here, you can see this is the displacement of, this is a 2. These are 2 squares to the right, positive. So that is 2. Then the y-axis, upwards, we have 1, 2, 3. So if you write this one in column form, that is vector A, will be given by 2 squares displacement to the right that will be 2. Then upwards positive on the y-axis, there are 3 squares. So that is 2, 3. For B, look at the starting point. Just 2 squares displacement to the right, the x-axis, that will be positive. So this is just 2 squares. So this will be 2. Then on the y-axis, none. There's no displacement because you can see the line is horizontal. There's no y displacement. For C, starting point is there. So displacement to the right, those are 2 squares. Then this one is very important. Then displacement to the y-axis is downwards, so that will be -2. So when you write that one in column form, it will be 2, -2. This will be very important as we add. Now from there, let me just use this grid here instead of using the other one to avoid repeating A and B and C. So now we want to add A plus B. So let me, B is there, not very clear. So A plus B. So we look at A. The starting point of A is here, the end point is here. So at the end point, that is where we are supposed to add B. So from here, end point, just 2. B is 2 squares displacement on the x-axis, no y displacement. So 2 squares like that. So that is B. So the end point is here. Once you've done that, to get A plus B, the starting point of A, join the starting point of A to the end point of B, just like that. And then looking at the direction of vector A plus B should head in that direction as well. So this now is A plus B. As simple as that. Now after doing that, that is the first part. The second part is the resultant vector A plus B plus C. A plus B plus C. So we need to get A plus B. A plus B. The displacement, A plus B. Look at the displacement on the x-axis to the right, A plus B. Those are 1, 2, 3, 4. Those are 4. Be given by 4 squares to the right. This is the displacement in the x-axis. Then upwards on the y-axis, these are 1, 2, 3 squares. So that will be given by column vector 4, 3, 4, 3. That is A plus B, given by that column vector 4, 3. Now after doing that, now we take A plus B. I can write this one, I can draw this one down here. A plus B given by 4, 3, 4, 3. So start from here. So 1, 2, 3, 4. That is a 4. Then 3. These are 4. Then 3, 1, 2, 3. Go up to there 3. So this is how it will be. That is vector A plus B. 4 squares. 1, 2, 3. I think this one is not 4. Let me read it again. Made a slight error there. So 4, 1, 2, 3, 4, 1, 2, 3, 4, 4. Then 3, 1, 2, 3, like that. So you can see this displacement here, the x-axis, those are 4 squares, that is 4. Then upwards, those are 1, 2, 3. The 3, that one is just for the purposes of explanation. That is vector A plus B. So you can clear that now. Now we need to add C. We need to add C, and C is negated by these. C is 2, -2. 2, -2. 2, -2. So at the end point, we count 2, that. The end point, we count 2. Then -2 is downwards, is -2. So the vector will be represented by this one now. This will be the vector C, that will be vector C. So displacement to the x-axis, to the right is 2. Then downwards on the y-axis, -2. So you don't require this one, just for explanation. So this is vector C. So therefore, A plus B plus C would be given by, you join these like that. You're using a ruler to do this, of course. Then the direction is that. So this is A plus B plus C. And that is how you're supposed to solve that question. Question 13. Given that matrix P is equals to 4, -7, 2, -1, Q is -1, 6, 5, -3, and R is equals to 20 multiplied by inverse of P plus Q. Determine the matrix R. So R is given by 20 multiplied by P raised to power -1 is the inverse of P plus Q. So the main thing here is how to get the inverse of P. So let's begin by getting the inverse of P. So P is there, matrix P is there. So to get the inverse of P, we start by getting the determinant. To get the determinant, you get this product, 4 times -1. Subtract the product of this diagonal, which is 2 times -7. So this will give -4, and then this will give plus 14, and this will give 10. So the determinant is 10. Now let's get the inverse. The inverse of P is given by 1 over the determinant. Then I want you to look at how these elements are interchanged. 4, -7, 2, -1 when you're getting the inverse. So this will be -1, -2, this will be 7, 4. So these are how we interchange the elements. So look at this diagonal here, 4, -1, and this one. So when you're getting the inverse, the elements in that diagonal are interchanged. So 4, -1, -1, 4. That is how we go about that. Then this one is diagonal here from 2, -7 to -2, 7. So what is happening? They are not interchanged, but the signs change. The signs are changing in the diagonal. So that is how we get the inverse. So we've got the inverse of P. Therefore R is equals to 20 multiplied by the inverse of P, which we have already obtained here is 1 over 10, then -1, 7, -2, 4, then plus Q. Matrix Q is -1, it is here, -1, 6, 5, -3, like that. So when you multiply these, because this one will give 2, so we divide 20 by 10, you get 2. So every element here in this matrix here, you have to multiply by 2. So you get this one as -2, this will be -4, this will be 14, this will be 8. So each of the elements here must be multiplied by 2 in this matrix that is here. Then we add -1, 6, 5, -3. So when you're adding, we simply, these are 2 by 2 matrix added to a 2 by 2 matrix. So you just add the corresponding element for the 2 matrices. So for example, we take this one, we take -2 plus -1, that will give -3. Okay, so let me just write it here. So -2 plus -1. Then for this one, -4 plus 5. So -4 plus 5. Then 14 plus 6. And then 8 plus -3 is how we go about it. So this one will give -3, 21, 5. And that is the matrix R. Question 14. In a sub-county, the number of children per family was recorded from 30 families. The data recorded is as follows. You can see the table there. Part A of the question represent the data in a frequency distribution table. And then part B, calculate the mean number of children per family. So we start by representing this data in a frequency distribution table. So the data that you can see, all these values that you can see, they represent the number of children per family. And there are a total of 30 family. So when I look at these values, the smallest is 0 and the largest is 7. So let me prepare the table. Here from 0. So I'll have this one as the number of children, which I will represent by X. Then here we'll have the number of families, which I will represent by F, which is the frequency. So from 0, the number of children, the least is 0, then 1, 2, 3, 4, 5, 6, and 7. So let's go to the families with 0 number of children. I only see 1, so it is 1. We go to 1. The families with 1 child is 1, 2. Then let me see whether there's another one, 3. So there are 3. We go to families with 2 children. We have 1, 2, 3, 4, 5, 6, 7, 8. Families with 3 children. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Go to the next. Families with 4 children, be 1, 2, 3. Families with 5 children, we have 1, 2, the 2. The next, families with 6 children, have 1, 2. And then we have families with 7 children, we only have 1. So it is as simple as that. So after doing that, now we have number of children x, then number of families, which is f. So that is the frequency distribution table. Let's go to the second part. Calculate the mean number of children per family. So to get the mean, which I'm going to denote by x bar, is equals to, we are going to get the summation of fx divided by the summation of frequency. So let me create here a column that is fx. X is the number of children, number of families f. Just multiply 0 times 1. We have 0. This will be 3. This will be 16. 3 times 10. This will be 30. This will be 12. This will be 10. This will be 12. This will be 7. Then I add everything. So I simply add the summation of fx, which is 0 plus 3 plus 16 plus 30 plus 12 plus 10 plus 12 plus 7. Then everything divided by summation of frequency. Frequency here is summation of frequency, which is already given. If you add everything here, you get 30. There are 30 families already. We are given that in the data there. Information, there are 30 families. Number of families are 30. So we divide by 30. So add everything here. And if you add 0 plus 3 plus 16 plus 30 plus 12 plus 10 plus 12 plus 7, you will get 90. Then you divide by 30. And this one will give you 3. So 3 is the mean number of children per family. Question 15. The equation of a curve is given by y is equals to 3x squared minus 2x. Determine the equation of a normal to the curve at x is equals to 2. So I'll begin by sketching this curve, just a sketch of the curve to help us work out. So assuming that that is the curve y is equals to 3x squared minus 2x. If you are to find the equation of the normal, we must start with the tangent. So assuming that the tangent is a line that touches this curve at this point, that is the tangent. And this point where it is touching this curve, so x is equals to 2. X is equals to 2. The normal will be perpendicular to the tangent. The normal is the line that is perpendicular to the tangent. It is important to note this, that normal is perpendicular to the tangent, or the tangent is perpendicular to the normal. It's just the same thing. So the normal is a line that will pass through that point, so it will be perpendicular, and both of them are passing through this point. X is equals to 2. So therefore the first thing that you need to get is this point. We have this point where the normal and the tangent are touching that curve. We only have the x coordinate, so we get the y coordinate, and to get the y coordinate we just use the function of that curve, because that point is on that curve. So y is equals to 3x squared. So x is 2 at x, so we just substitute minus 2x, and this will be 4, this will be 12 minus 4, and this will be 8. So this point is therefore 2, 8. This point here is therefore 2, 8. That point where the tangent and the normal are touching the curve is 2, 8. So we shall begin by getting because we need the equation of the normal. For us to get the equation of that normal, which is a straight line, we will need 1 point and the gradient. So how do we get the gradient? We shall start by getting the gradient of the tangent, and I will let the gradient of the tangent to be noted by m1, the gradient of the normal to be noted by m2. So how do I get the gradient of the tangent? I'll get that by differentiating the function of that curve, because that point 2, 8 is on that curve. So I get, so this is y is equal to the function of the curve 3x squared minus 2x. So the gradient will be given by, this is the function, the expression that is going to give us the gradient. So we get dy dx, we differentiate that. This one will give us the gradient function, and we're going to use the gradient function to get the gradient of the tangent. So differentiate this with respect to x, you get 6x minus 2. That is the gradient function. Now to get the exact gradient of the tangent, because this point x is equals to 2, we just saw at x is equals to 2, just substitute, be 6, 2 minus 2. And this will give 12 minus 2, which will give 10. So the gradient is 10. So the gradient is 10. That is the gradient of the tangent, M1. So having got that, we can now proceed and get the gradient of the normal. Since the normal is perpendicular, the tangent, you know that if two lines are perpendicular to one another, if you take the product of their gradient, you should get -1. So M1 is 10. So M2, which is the gradient of the normal, will be, M2 will be -1/10. Simple as that. Now having these, we'll be able now to get the equation of the normal, because on the normal, we have a point. We have a point. It's a common point shared by the tangent and the normal. The point is 2, 8. And we have the gradient. So what we do, we just introduce another general point on that normal. Call that point xy. So I'll introduce another point xy on the normal. Then I'll use these 2 points, 2, 8 and xy, to get the equation. So using these two, 2, 8 and xy, get the gradient. Gradient is change in y, so y minus 8, that is change in y, divided by the change in x minus 2. That is how we get the gradient, and we know that gradient, M2, it is -1/10. From here you can cross multiply. You have y minus 8 multiplied by 10, like that. Then x minus 2 multiplied by -1. So this will give 10y minus 80 is equals to -x plus 2. So I want to express it in the form y is equals to mx plus c. So 10y is equals to -x plus, I take -80 to the right hand side, or I add 80 on both sides to eliminate it on the left hand side. I'll get this one is 82. So divide everything by 10. So y is equals to -x/10 plus 82/10. And this one we can simplify to y is equals to -x/10 plus, can simplify this by 241/25. So you can write it as 41 divided by 5. And that is the equation of the normal at x is equals to 2. Question 16. On the following Cartesian plane provided, solve the simultaneous equations. Y is equals to 4/3 x plus 2. Then the second one is 3y is equals to x minus 3. Now to solve this simultaneous equation graphically, we are going to draw each of these lines using the equations provided. So we start with the first one. For us to draw a straight line using the equation, we need at least 2 points. And let me start with the first one. So the first one is y is equals to 4/3 x plus 2. So let me prepare a table where I will require to have at least 2 points. Should be very keen with the points that you use, also considering the graph paper that you're given. Look at the values, both the negative, positive, both the axes, to ensure you don't get big values. Then another thing, choose values that are not going to give you decimals or fractions. It will be easier to plot them. So using this function y is equals to 4/3x plus 2, the first one that you can try is when x is 0. So you just substitute where we have x, just substitute that one with 0, and you notice y will be 2. When another value that will not give you decimal or fraction, think of value like 3. When x is 3, that will be 4/3 multiplied by 3. That will be 6. It will give us 6. Then another one you can choose and think of -3. That will be -2. So this is what you're supposed to plot. You can see all the values 0, 2, 3, 6 and -3, -2. It is possible to plot all these on the graph. The other equation, so the other equation is 3y is equals to x subtract 3. So we have x, we have y. So we can start with when x is 0, just substitute when x is 0. Y will be -1. Then talk of 6. If I go to 6, I'm trying to look for values that will not give me negatives and not give me. So I'm looking for values that will not give fractions or decimals. So 3 is okay. When x is 3, y is 0. Then when the other one you can choose is when x is 6, then y will be 1. So that is all. Now you have the values that you're going to use to plot. So the first line is y is equals to 4/3x plus 2. Let's plot 0, 2. 0, 2 is here. Zero, 2 is there. Then 3, 6. 3, 6 is here. 3, 6 is there. Then -3, -2. -3, -2 is here. So once you've done that, join those points using a straight line. Ensure that your line is passing through all the 3 points. That. Then the other line, 3y is equals to x minus 3. 0, -1. Plot that. 0, -1 is here. Zero, -1 is down. Then we have 3, 0. 3, 0 is there. Then 6, 1. 6, 1 there. So draw a straight line. So draw a straight line passing through the 3 points. Like that. So those are the 2 lines. So we have this line, y is equals to 4/3 x plus 2. And we have this one, 3y is equals to x minus 3. Now to solve the simultaneous equations, check the point of intersection of the 2 straight lines. And this is the point. This is the point where the 2 lines are meeting, and this will be the solution. So give the coordinates of this point, and these are -3, -2. So -3, -3, -3, -2. So in this case, x is therefore, the x coordinate is -3 and y is -2. So these are the solutions. That is how you solve simultaneous equations graphically, by simply drawing the lines and getting the point of intersection. The coordinates of the point of intersection gives the solution. Question 17. 2 towns, A and B, are 400 kilometers apart. A motorcyclist traveling at an average speed of 60 kilometers per hour left A for town B at 1:20 p.m. A matatu traveling at an average speed of 80 kilometers per hour also left town A for B at 2 p.m. A, calculate the 1. Distance covered by the motorcyclist by 2 p.m. So how do we get distance? Begin from there. Distance is obtained by taking the speed multiply by the time taken. In this case, you're looking at the motorcyclist. What is the speed of the motorcyclist? It is 60 kilometers per hour. Then what about time? Which time are we considering? It left A at 1:20 p.m. We are required to get the distance by 2 p.m. So time will be given by this difference. The difference from 2 p.m. 2 p.m. is the same as 1400 hours, and 1:20 p.m. is 1320 hours. So the difference here is 40 minutes. So therefore you're required to get the distance covered by the motorcyclist from 1:20 p.m. to 2 p.m., which is 40 minutes. So we multiply by 40 minutes. We can't work with minutes and hours, so we have to convert 40 minutes to hours by dividing it by 60. So this will give hours. So this is equivalent to 60 kilometers per hour multiplied by 2/3. 40 over 60 is 2/3 of an hour. And when you work out these, you'll get 40 kilometers. That is the distance. Part 2, the distance from town A in kilometers where the matatu caught up with the motorcyclist. Distance from town A where the matatu caught up with the motorcyclist. So we've just noted from the statement that both the motorcyclist and the matatu are moving towards the same direction. They are moving from A. So let me draw. So that is the two of them. So this one, the first one is the motorcyclist, then this one is the matatu. This is A, this is the destination, which is B. By the time the matatu was beginning the journey, because it left A for B at 2 p.m., the motorcyclist had already covered a distance because the motorcyclist had begun the journey at 1:20 p.m. and we have noted that distance is 40 kilometers. So therefore the distance between the two by 2 p.m., because the p.m. that is when the matatu was beginning the journey, is 40 kilometers. So that is the distance between them. That is the first thing we need to first understand. Relative distance. That is the distance between the motorcyclist and the matatu by 2 p.m. is 40 kilometers. We need to find the time taken to catch up. The time taken to catch up. And how do we get time? This time will help us to get the distance. Time is given by distance divided by speed. We already have the distance as 40 kilometers, the distance between them. And now, what about the speed? The two of them are traveling in the same direction, that is from A. So we need to get a relative speed, and to do that, because they are moving towards the same direction, we shall get the difference of their speeds. The speed of the matatu, which is 80 kilometers per hour, subtract speed of the motorcyclist, which is 60 kilometers per hour, and this will give the relative speed as 20 kilometers per hour. Now we have what we require to get time taken to catch up. So time to catch up will be given by relative distance, that is distance between them by 2 p.m., which is 40 kilometers, divided by relative speed, which is 20 kilometers per hour. And this will give 2 hours. So 2 hours is the time taken to catch up. The question is distance from town A in kilometers where the matatu caught up with the motorcyclist. Distance from A. So for that, there are 2 ways you can get that. You can decide to use the motorcycle or the matatu to get the distance from A. If I decide to use the motorcycle to get distance from A, so distance is given by speed times time. So the speed of the motorcycle is 60 kilometers per hour times time taken to catch up, which will be 2 hours. This will give 120 kilometers. But what we have already obtained as 120 kilometers is not the distance from A. It is the distance from this point where the motorcyclist had already covered 40 kilometers. So let's assume that this is the point of the two of them meeting. So the distance we have obtained from this point is this 120 kilometers. That is the distance we have. So from where 40 kilometers was covered. So that is the distance we have. But if you want to get the whole distance from A, we have to add 40 plus 120. So we have to add 40 kilometers. That is the distance covered in 2/3 of an hour, as we noted in part A. So this will give 160 kilometers. That is the first way. The second way is when you decide to use the matatu from A. So the matatu had not covered any distance, so we'll go directly and we get speed times time. And this will give the speed of, it was moving at a higher speed, was 80 kilometers per hour. Then time taken to catch up was 2 hours. So this one will still give you 160 kilometers. So the same answer. So that is the distance from town A. Part 3, the time when the matatu caught up with the motorcyclist. Time when the matatu caught up with the motorcyclist. So the matatu began the journey at 2 p.m. Then the time taken to catch up is 2 hours. So we just need to add 2 hours. And this will give 4 p.m. Or you can give it as 1600 hours. That is the time when the matatu caught up with the motorcyclist. Part B, a lorry traveling at an average speed of 40 kilometers per hour left town B or town A at 2 p.m. Determine the time when the lorry and the matatu met. So now we have a lorry. Let me just draw these. So that is, so draw these because now they are moving in opposite direction. So one is for the matatu. Matatu was moving. The first one here is this one is the matatu moving from A to B. This is A, this is B. Then the lorry left town B to A. So it is moving in that direction at 2 p.m. And then matatu, we've noted in first part there, the first part, the matatu left at 2 p.m. So they left at the same time. So it left as 2 p.m. as well. So determine the time when the lorry and the matatu met. How do we get these? To get the time, we need to get the distance divided by the speed. Which distance do we consider? The distance between the matatu and the lorry is here, is 400 kilometers. So that is distance, 400 kilometers, the distance between them. Then for the speed, in order to get the time taken to catch up, we're going to use the relative speed. They are moving towards each other. Okay, they are moving towards each other in opposite direction, that is. So how do we get the relative speed in such a case? By simply adding the two speeds. This is quite different from the first part. From part 2, when you're getting the relative speed, we subtracted. Why? Because they were moving in the same direction. When they're moving in the same direction, you subtract the speeds. But if they are moving in the opposite direction or towards each other, you add. So we'll take the speed of the matatu, which is 80 kilometers per hour, plus the speed of lorry, which is 40 kilometers per hour, like that. So this will give 400 kilometers divided by 120 kilometers per hour. That is 80 plus 40. And when you work out this will give a 40 divided by 12. This will give 3 1/3 hours, or simply 3 hours and 1/3 of an hour is 20 minutes. So that is the time taken for them to meet. The question is determine the time when they met. To get the time, since they had started at the same time, 2 p.m. Both of them started traveling at 2 p.m. So time taken to meet is already there, 3 hours 20 minutes. So you just take 2 p.m. plus time taken to meet, which is 3 hours and 20 minutes. Here, whichever you use, we'll use the lorry. Matatu is still okay. So this will give 5:20 p.m. or 17:20 hours. That is the time and the lorry and the matatu met. Question 18. On the following grid, triangle PQR is drawn. You can see it there. First question, part A. On the same grid, draw Roman 1, triangle P prime, Q prime, R prime, the image of triangle PQR under a reflection in the line y is equals to 0. It's good to note that y is equals to 0 is the line x-axis. This is the x-axis. That is the equation of the x-axis. So that is the first thing you're going to do. So we reflect these PQR under the line y is equals to 0, the x-axis. So the x-axis is going to act as the mirror line. So to do that, we know the property of reflection. The object and the image should be equidistant from the line of reflection. We start with Q. Look at the distance between Q and the x-axis. Those are two squares. So from this point here, from 2, 0, you count two squares, 1, 2. So you'll have Q prime there. Then look at R. R to the line of reflection, that is the x-axis. How many squares? 1, 2, 3, 4. So from the x-axis, you count 4 squares. 1, 2, 3, 4. It will be here. So that will be R prime. Then P, distance from P to the x-axis. 1, 2, 3, 4. So 4 again. And it should be perpendicular. So from this 1, 2, 3, 1, 2, 3, 4, it should be here. So this is a P prime. Then you join that. So you join, that is P prime, Q prime, R prime. So that is how you're supposed to do that. Another important thing to note, I want you to look at the coordinates. For example, you can take one. You can take Q, the coordinates of Q. Q is 2, 1. Then under the reflection, the x-axis is mapped onto 2, -1. This is a Q prime, 2, -1. Notice that under reflection of any image, the coordinate that is under the reflection in the line x-axis, what changes is the y-coordinate. The y-coordinate changes the sign. The x-coordinate remains constant, doesn't change. So that is what is happening across all the other P and R. So that is part A. Part 2, triangle P double prime, Q double prime, R double prime, the image of triangle P prime, Q prime, R prime, the one that we've just drawn, under enlargement scale factor -1.5, center O, the origin. So enlargement. So whatever we have drawn is enlarged through center, origin, and the scale factor of enlargement is -1.5. So the first thing we do in enlarging, we join all the object points to the center of enlargement using a straight line. So we start with P. So join P, the center of enlargement, like that, using a straight line. Then you go to Q, same to Q, then R, like that. So after joining, take a pair of compass. So after joining all the object points, this is P prime, R prime, and Q prime to the center of enlargement. Now, how do we go about -1.5? Enlargement of -1.5. How do we count that? Take that distance. That is the distance you need to take. P prime to the center of enlargement. Then with that measurement, go to the center of enlargement, which is the origin, the center of enlargement. So you need to, that is, if I mark an arc here, that will be enlargement by 1. Made mistake there. Slight mistake. So if I mark an arc there, that is enlargement by 1. So enlargement by 1.5, you take half of that distance. Take half of that distance. And half of that distance is around there. That is half of that distance. Then now from here, I'll stand at that point and mark that. So that will be 1.5, 1.5 times. Another simpler method you can use, just count the number of squares along that straight line from P prime to the center of enlargement. Count the number of squares. They are 1, 2, 3, 4. Those are 4 squares. So 1.5 times. So 1.5, 1.5 times 4 squares. These will give 6 squares. That means from the center of enlargement you simply be required to count 6 squares. 1, 2, 3, 4, 5, 6. And this is where you shall have P prime. That is the easiest way. So now let's get R double prime. So this was P double prime. You've seen you're counting 6 squares from the center of enlargement. So from the center of enlargement along that straight line of R prime. So just count 1, 2, 3, 4, 5, 6. So it will be here. So this is where we shall have R double prime. Then for Q, follow that straight line. From the center of enlargement, count 6 squares. 1, 2, 3, 4, 5, 6. To be here. That is Q double prime. Then you join. So that is triangle P double prime, Q double prime, R double prime. So after doing that, we go to the next triangle, that is part 3. Triangle P triple prime, Q triple prime, R triple prime, the image of triangle P double prime, Q double prime, R double prime, and a half turn about the origin. So whatever we have drawn, now we need to rotate that and the half turn about the origin. So this one is quite simple, because we just need to understand what is half turn about the origin. Half turn is 180. So half turn is 180 degrees. Either side, whether it is negative half turn or positive half turn, it will not change anything. 180 degrees, that is a straight line. So we start with P. So for P, if you measure along that straight line, need to extend this. So I'll have to extend this line. So let me extend it. I have to extend these lines here. So you extend those lines like that. Then 180 degrees, starting with P double prime. So when you place a protractor, the center marking the origin there, you can see. So 180 runs all the way from this point, that is 180, all the way to this is a straight line. So that is 180. Now to rotate that P double prime through 180 about the origin, you just need to count the number of squares, or take that distance from P double prime to the origin. Take that distance. For me, I'll just count the number of squares from P double prime to the center. Those are how many squares? 1, 2, 3, 4, 5, 6. Along that straight line, because we've noted 180 will be that will be 180 for all of them. That is 180 degrees. So from the center of rotation, you count 6 squares. 1, 2, 3, 4, 5, 6. So you'll notice P triple prime will be located there. So 1, 2, 3, 4, 5, 6 squares. So from the center of rotation to P double prime along that straight line, 6 squares. Then from the center, that is the origin, to P triple prime, 6 squares. You do the same for all the others. Now let's go to R double prime to the center along that straight line. So there are still 1, 2, 3, 4, 6 squares. So from the center, you count 6 squares again. 1, 2, 3, 4, 5, 6. So it will be here. This will be R triple prime. Then for Q, along that straight line, there are still 6 squares from Q double prime to O. Count 6. You can use either, you can take that distance using a pair of compass and transfer it, or you can count the squares. I'm counting the squares because my scanned graph is not that accurate enough to get the measurement, the accurate distance. So from the center or point O to Q triple prime, count 1, 2, 3, 4, 5, 6. So it will be here. That is a Q triple prime. Then you join. Me recheck for R. We check for R. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oh yeah. You can see for R, I have to correct for R. R is supposed to be here. I noted that. So from R double prime to the center, that is 6 squares. So from the center, count 6 squares. 1, 2, 3, 4, 5, 6. So it will be here. R triple prime will be there. So join and it like that. You have it. So there is P triple prime, R triple prime, Q triple prime is there. The last question, describe a single transformation that maps P prime, Q prime, R prime to P double prime, R triple prime, Q triple prime, R triple prime. So these two, which transformation maps this triangle to this? You can shade that. The transformation that will map that triangle, I've shaded in yellow, and the one that would map it to this one, the next one. So those two I've shaded. So which transformation would map this triangle to this? When you just look at P prime, Q prime, and R prime, when you just look at these P prime, R prime, Q prime, and then you look at P triple prime, Q triple prime, R triple prime, you notice that is an enlargement. The triangle has been enlarged. And if it is an enlargement, because it is obvious it is enlargement, how do you describe an enlargement? By giving the center of enlargement and the scale factor of enlargement. To do that, you simply join any two object and image point using straight line. For example, you can decide to join Q prime to Q triple prime using a straight line. Extend it, then choose another one, P prime. You can choose these. We have P prime and P triple prime. Join that using a straight line, as you can see. And we've chosen this one, join. Where those two lines are meeting when they're extended, that becomes the center. That is the center of enlargement. So the center of enlargement is the origin, or point O. Then the scale factor. How do you get the scale factor? You can simply do it like this. So to get the scale factor of enlargement, this is what you do. You can get it by scale factor is given by from the origin to the image point, which is P triple prime. Divide that one by from the origin from point O to P prime. So get that distance. So from the origin to P triple prime, get that distance. How many squares are they? 1, 2, 3, 4, 5, 6. Those are 6 squares divided by, what about from O to P? So 1, 2, 3, 4. Those are 4. The 4 squares. Those are 4 squares. So when you divide that, you will simply get 6 divided by 4. You get 1.5. You get 1.5. So 1.5 is the scale factor of enlargement. So this is how you describe it. Just say it is an enlargement, center the origin, and the scale factor of enlargement, we've got that one as 1.5. So that is how you're supposed to solve that question. Question 19. The following figure shows a right pyramid VABCD. The base ABCD of a pyramid is a square of side 8 centimeters. As you can see, the length of the slanting edges VA is equals to VB is equals to VC is equals to VD is equals to 10 centimeters. So you can see the diagram there. So the right pyramid of the slant heights are equal. First question, calculate the vertical height of the pyramid correct to 2 decimal places. Vertical height. So to get the vertical height, we shall need first to draw a straight line from A to C, and then the height, we create the center of that line, the midpoint of AC will be there, and it is from this center that we shall create a height. So the height will be there. So this will be the height. You can call this midpoint of AC to be O, point O. Now to get the vertical height, we'll need to consider triangle VOC. For triangle VOC, we have VC as 10 centimeters. So we need to get the length OC. And to get OC, since the base is a square, and being a square, all these angles here, these are right angles. So if we use triangle ABC, so triangle ABC is a right angled triangle, and we can use that to get AC. So therefore AC will be given by, that is the hypotenuse, 8 squared, that is AB, plus BC. That will be given by 8 squared plus 8 squared. You get the square root of that using Pythagoras theorem. So this will give 64 plus 64, which will give the square root of 128. So get the square root of 128, which will give 11.31 centimeters. That is AC. So to get OC will be a half of AC, because O is the midpoint. So OC will be a half times 11.31. So we simply take 11.31, we divide by 2. That will give 5.657. So that is OC. Now having OC as, so this one here is 5.657, and we have 10. We have VC as 10. Now in that right angle triangle VOC, we can now calculate the height using Pythagoras theorem. So VO, which is the height, now will be given by, we consider that triangle VOC. Hypotenuse is 10, so it will be 10 squared minus OC squared, 5.656 squared. You get the square root of that. So that is what you're supposed to do. So this will be 100 minus 5.656 squared will be the square root of 68.001. And when we get the square root of that, this will give 8.247 centimeters. So that is the vertical height VO. We go to part B, the surface area of the pyramid. The surface area of the pyramid. Now to get the surface area of the pyramid, we need to get the area of all the surfaces. And we are going to begin with the base. The base is a square. The base, which is a square, and the area of the square will be given by 8 centimeters by 8 centimeters. 8 centimeters times 8 centimeters. This will give 64 centimeters squared. Then we have all the slant faces. They are equal. All the slant faces. This one is a right pyramid, so all the slant faces are equal. The slant heights are 10. So if you're able to get the area of just one, V, A, B, this is 10, this is 10, and this one is 8. So if you're able to get the area of one face, we just need to multiply by 4, because there are 4 slant faces. So how do we get the area of this one slant face, which is in the shape of a triangle? And this is a triangle with all the measurements given. So the easiest way is to use the Hero's formula. So we can use the Hero's formula. So the slant faces is 8, this is 10, this is 10. So use the Hero's formula, and the Hero's formula goes like this. So we shall first add. We add, first of all, let me write it here. S minus A, S minus B, S minus C, where S is half the sum of all the faces. That is 10 plus 10 plus 8. And this will give, so this will be 28 to be 14. So S is 14. Simply get half the sum of the length of all the 3 slant lengths. So we can take this as A, this is as B, and 8 as C. So we just substitute. So this will be the square root of S is 14, then 14 minus A is 10, 14 minus B is 10, then 14 minus 8, that is C. It will give 14 multiplied by 14 minus this will be 4 times 4 times 6. So when you get the square root of this, now 14 times 4 times 4 times 6, this will give the square root of 1344. And this will get the square root of this, you get 36.66 centimeters squared. So that is the area of one slant face. So to get all of them, because there are 4, we simply multiply this one by 4. This one, when you multiply it by 4, you'll get 24. You get so the square root of so you multiply by 4, we get 146.6. that. Now for the first part, just a point to note here. Part A, calculate the vertical height of the pyramid, correct 2 decimal places. Correct 2 decimal places, forgot to write this one, correct 2 decimal places. This is supposed to be 8.25. It's very important to note that 2 decimal places, 8.25. So let's proceed with the other one. So after multiplying by 4 to get the area of all the slant faces, we get that. Now the total area will therefore be the base. We got the area of the base is 64. Then we add the area of all the slant faces, which is 146.6 centimeters squared. So this will be 64 plus 146.6. So this will give 210.6 centimeters squared. So that is the total surface area. Then part C, the volume of the pyramid. The first thing you need to understand is how do you get the volume of the pyramid? So volume of the pyramid is given by that base area times height. We have that times the base. The base is a square. Base is a square measuring 8 by 8. So the base area will therefore be 8 times 8. Then times the height. We got the height from the first part. The vertical height, we got it as 8.25. 8.25. So that will give us the volume. So we have 64 multiplied by 8.25. Get that. Then we divide by 3. So that will give 176. So 176 centimeters cubed. So that is how you're supposed to solve that question. Question 19. Question 20. Naima went to the market to buy bananas worth 2,100 for a school. The seller offered a discount of 3 shillings per banana, which enabled Naima to buy 35 more bananas. Part A. Taking X shillings as the price per banana before the discount, write an expression for 1. The number of bananas that Naima would have bought before the discount. So before the discount, Naima had gone to buy bananas worth 2,100 shillings, and each banana was costing X shillings. That is before the discount. So to get the number of bananas that she bought before the discount, you'll take the amount, which is 2,100 she had, then divide by the price per banana. So 2,100 divided by X would represent the number of bananas before the discount. Then part 2, actual number of bananas that Naima bought after the discount. Now, given in this statement, the seller offered a discount of 3 shillings per banana, which enabled Naima to buy 35 more bananas. So to get the actual number of bananas, again, we'll take the amount she had, that is 2,100. Then the price per banana. The price per banana is not now X. After the discount, you subtract 3 shillings. The initial price per banana was X, but a discount was given. So if it's a discount, you subtract 3, discount of 3. So now this is the cost. So you have to divide by X, subtract 3. That now would represent the number of bananas after the discount. Or alternatively, you can do it like this. After the discount, she was able to buy 35 more bananas. So you can simply work out with the figure before the discount. That is, those are the number of bananas that she was able to buy before the discount. But after the discount, she was able to buy 35 more. So also this expression can work after the discount. So you can either write it as X, 2,100 divided by X minus 3, or the second one, 2,100 divided by X plus 35. Part B, form an equation in terms of X and hence determine the actual number of bananas bought. So with the expression in A part 1 and A part 2, we can be able to form an equation in terms of X. So in the second equation, this was when she was able to buy more bananas. So if we take the equation in part 2, because this is where she was able to buy bananas, if you subtract the number of bananas that she was able to buy after the discount, which is 2,100 divided by X minus 3, you take that and subtract the number of bananas that she was able to buy before the discount, that one should give 35, because in the second part she was able to buy more banana. That is in part 2, after the discount she was able to buy 35 more. So that expression is what you're going to use and to give you the number of the actual number of bananas she was able to buy. So now we need to solve this equation. And solve this equation, you can begin by dividing this one by 1. So you can divide that one by 1. Look at the denominator. Get the LCM of x minus 3 and x, and then 1, which will give x minus 3. Then multiply each term by that LCM. So for example, you can take 2100 divided by x minus 3. You multiply that by the LCM, which is x minus 3. Then subtract 2100 divided by x. Multiply that one still by the LCM x minus 3. Then is equals to 35. Again, for this one, you multiply by x minus 3, like that. So when you solve this, you'll be able to get the value of x. So let me cancel out. So x minus 3 will cancel there. X there will cancel. And this is what you're going to have. For this one, you'll have 2100x. Then minus. For this one, you'll have 2100 brackets x minus 3 is equals to, this one will give 35x squared minus 105. This will give 2100x minus 2100x plus, when you open the bracket, 2100 times 3, you get 6300 is equals to 35x squared minus 105x. Then from there, there's something that you'll note. This one and this one, you subtract 2100x minus 2100x, you'll eliminate that, and then you'll be left with this. You can organize this one, can organize that one to form a quadratic equation, and this is what you get: 35x squared minus 105x. And you take 6300 to the right hand side, you get negative 6300 is equals to 0. So you can simplify this by dividing all these terms by 35. Divide everything by 35, and this one will give x squared minus 3x minus 6300 divided by 35. That will give 180 minus 180. Now this one is a quadratic equation. You can use the quadratic formula or factorization. Let me use factorization. Look for two numbers whose product is negative 180 and sum is equals to negative 3. The numbers are these numbers are negative 15 and 12. Negative 15 and 12. So solve these. So give x squared. So write negative 3x using negative 15 and 12. So negative 3x will be given by negative 15x plus 12x minus 180 equals to 0. So these factorize x minus 15, then plus 12 x minus 15 is equals to 0. So these will simplify to x plus 12 x minus 15 is equals to 0. In this case, you have two answers. X plus 12 is equals to 0. So here x will be negative 12. We will ignore this because x represents cost, cannot be negative. So then x minus 15 is equals to 0. So here we get x is equals to 15, and this will be the solution. So x, we found x, and remember x is the price per banana before the discount. So now the actual number of bananas that she bought, of course, that will be after the discount. So after the discount from the second expression, the actual number of bananas bought will be 2100 divided by x minus 3. 2100 divided by x minus 3, which will be 2100 divided by 15. X is 15 minus 3. And these will give, when you work it out, you get 175 bananas. So that is the actual number of bananas nameable. Part C. The bananas were given to students in a school. 2/5 of the students got 2 bananas each, while the rest got a banana each, that is 1 banana each. Determine the number of students in that school. So we're supposed to determine the number of students. So because we don't know the number of students, we can let the number of students be represented by x. So 2/5 of the students will be 2/5 of x. They got 2 bananas each, so you have to multiply by 2 that. And the rest 2/5 got 2 bananas. So the rest is 5 divided by 5 minus 2 divided by 5. The rest will be 3/5. So the rest will be 3/5 multiplied by the number of students, which is x, and this one got 1 banana each, so you just multiply by 1. And we know the total number of bananas, so you're going to equate by that to 175. So work out these. 2/5 x times 2, this will give 4/5 x, plus this will give 3/5 x is equals to 175. Now simplifying this, you'll get 4/5 plus 3/5, you get 7/5x is equals to 175. You want to remain with x, make x the subject, so multiply both sides by the reciprocal of 7/5, which is 5/7 times 5/7. So therefore x will be 175 times 5/7, and this will give 125 students. So that is the number of students in the school. Question 19. Question 21. The end-term test scores of 100 students were recorded as shown in the following table. So their scores, number of students are given there. Part A, state the model class. The model class is the class with the highest frequency, and that one is, look at it, is this class, the class with the frequency of 32 students, that is 60 to 69. So that is the model class. Part B, calculate the median score. The median score, so this is how we get the median. So median is given by L plus n over 2. I'll explain what this one means, divided by f, everything multiplied by I. That is the formula we use to get the median of a group data. And the first thing you're going to do is to get the position of the median. The position of the median. Position of the median is given by half multiplied by total frequency. This is n, which is 100 students. So the position of the median is 50. So to get 50, we'll need to get the cumulative frequency from this table, and this is how we get the cumulative frequency. This will help us to identify where 50 is. So 8 plus 10, this will be 18. 18 plus 28, this will give 46. 46 plus 32, that will give 78. 78 plus 12, that will give 90. Then 90 times 90 plus 10, that will give 100. That is cumulative frequency. So identify, where do we have 50? In which group is 50 found? It is here. 50 is here. But we have 78. That is where the 50th position is. And therefore, the median class will be this class from 60 to 69. That is where we have the median. We get the median from there. So now let us use this formula to calculate the median. So median therefore is given by L is the lower class boundary of the median class. So the median class is 60 to 69. So lower class boundary is 60 subtract 0.5. That will be, this is 59.5. So L represents the lower class boundary of the median class. And the median class is 60 to 69. So the lower class boundary, you take 60, subtract 0.5, that will give 59.5, plus n is total frequency. So when you divide 100, n is 100 divided by 2, that will be 50. Subtract CF is the cumulative frequency above the median class. Cumulative frequency above the median class. And the cumulative frequency above the median class is 46. So the cumulative frequency of the median class is 78. So the cumulative frequency above that class is 46, divided by the frequency. F is the frequency of the median class, which is 32. And then I is the class size. the class size of the median class. So the median class is 60 to 69. So to get the class size, you simply take 69.5 minus 59.5. And this will give 10. So that is how we get the median score. So we work out these. So we get 59.5 plus, this will give 4 divided by 32 times 10. That is how we get it. So this will be 59.5 plus, this will be 40 divided by 32. So you get 60.75. 60.75 as the median score. Part C, on the grid provided, represent the above data using a histogram. So to draw a histogram, we require to plot the frequency density. So you'll need, on the y-axis, you'll need the frequency density. And then on the x-axis, you'll need the upper class boundary. So the upper class boundary, we identify the upper class boundary of the first class. So here the upper class boundary will be 39.5. Here will be 49.5. Here we shall have 59.5. Here we have 69.5. We have 79.5, then 89.5. Then we need to have the frequency density. So how do we get the frequency density? So frequency density is obtained by, let me read it here. So frequency density is given by frequency divided by the class width. Frequency divided by the class width. So that is what you're going to do for all these. Don't have enough space here. So frequency is the number of students. So like the first class, 30 to 39, the frequency is 8. So to get the frequency density, you take frequency, which is 8, divide by the class width. The class width is 10. To get the class width, like for the first class 30 to 39, you simply take 39.5, the upper class boundary, subtract the lower class boundary, which is 29.5. You get the class size is 10. That is what you do for all the classes. So the frequency density for the first class will be 8 divided by 10. That would be 0.8. So I'll write it here down here, 0.8. Now for the second class, the frequency is 10. So 10 divided by 10, that will be 1. The other one is 28 divided by 10. That will be 2.8. Then the other one is 32 divided by 10. That will be 3.2. 12 divided by 10. 12 divided by 10 will give 1.2. Then 10 divided by 10, you get 1. So that is the frequency density for all the classes. So you can see the class size is uniform. So you're just taking the frequency divided by the class size. Now we need to plot now. Decide on the scale that you're going to use. For the y-axis, you can see the lowest there is 0.8, the biggest is 3.2. So we can use a scale of 1 centimeter, 2 centimeters, 2 centimeters to represent 1. So let me draw the axis. So use this one as there. So that will be the x-axis, then the y-axis. So begin from here. 0, and the x-axis is supposed to plot the lower the upper class boundary. The first one will be 39.5. So we can start a bit lower than that. So 29, we start from the lower class boundary of that class. So 20, so here you can have 29.5. And then he'll have 39, then he'll have 49.5, 59.5, 69.5, 79.5, and then lastly 89.5. Can break this scale here, since that is the only place where the scale is not uniform. Then for the y-axis, you can decide to use 2 centimeters to represent 1. So this will be 1, then this will be 2, then this will be 3, then that one will be 4. So that we can have one small square to represent 0.1. So now we can plot can draw the bars. So the frequency density for the first class is 0.8. So the class from 29.5 to 39.5, that is the class 29.5 to 39.5, that is 0.8. So 0.8 is here, so like that. So that is the first class. Then the second has a frequency density of 1, that one. You use a ruler to do this. Then the third one has a frequency of 2.8. So 2.8 is to hit this point. So 2.8, that bar is there. Shade that one as well. Then the next one is 3.2. 3.2 is up to that point. So you draw that bar. Then the next one is 1.2, that point, so shade that bar. And then the last one, 1. So those are the bars. You've drawn the histogram. On the y-axis you have the frequency density. We've been using these figures here. So for the first class, 29.5 to 39.5, the frequency density is 0.8. That is what we've drawn. The second class, 39.5 to 49.5, the frequency density is 1. The other class from 49.5 to 59.5, the frequency density is 2.8. The next class, 59.5 to 69.5, the frequency density is 3.2. And then the other class, 69.5 to 79.5, we have the frequency density is 1.2. And lastly, 79.5 to 89.5, the frequency density is 1. So that is how you draw the frequency, not the frequency, the histogram. That is how you draw the histogram. So that histogram is now complete, and the scores are here. This is where we have the scores, and then the frequency density there. So the last one, use the histogram to determine the number of students who scored from 71.5. So from 71.5 to 76.5. You're determining the number of students. So one thing that you realize, for you to get the number of students from this histogram, the number of students is given by the area. When you get the area of each bar, that will give you the number of students. And how do you get the area of each bar? By getting the width of that bar multiplied by the frequency density. And this one is given by width of the bar times the frequency density. Now, for example, for us to get the width of this bar from 71.5 to 76.5, the width will be 76.5, getting the difference of the scores. That will be the width, then multiply by the frequency density. What is the frequency density of that class where these marks lie? 71.5 to 76.5. Where does that one lie? It lies on that class where we have 69.5 to 79.5. This is why it is here. That is where the marks lie, 71.5 to 76.5. Then that class, 69.5 to 79.5. And what is the frequency density of that class? It is 1.2. 1.2 is in this class, this specific class here. The frequency density there is 1.2. So to get the number of students, you take the width of that class, then you multiply by the frequency density. So do this. So 76.5 subtract 71.5 and then multiply that one by 1.2. And that will give 6. That will give 6 students. That is how you're supposed to solve that question. Question 22. The following figure shows a quadrilateral PQRS and a circle passing through the vertices P, R, and S. Lines PQ is equals to PR is equals to 2.7 centimeters, PS is equals to 6 centimeters, SR is equals to 7 centimeters, and angle PQR is equals to 65 degrees. So the diagram is there. with all the measurements indicated. A part 1, you are supposed to calculate the length of QR. Let's go to the diagram. QR. So you can see QR, where QR is. So to get that, consider triangle PQR. You're given two sides, 2.7. QP or PQ is 2.7 and PR is 2.7, meaning this one is an isosceles triangle. And if that is the case, it means that this one is also 65 degrees. And the remaining angle, because of the sum of angles in a triangle, this will be 50 degrees. So having two given sides and an angle, we can use sine rule and we'll be able to get this. Sine rule, if I let the side opposite P be denoted by small p, side opposite R to be denoted by small r, side opposite Q, small q. This is the sine rule. The sine rule given using this, P over sine of P is equals to R over the sine of R is equals to, the other one is Q over the sine of Q. QR is the side I have denoted with P. So I can pick this. That will help me in getting QR. So P which is a QR, so P over the sine of P is equals to R. You can use R over sine of R, or you can use Q divided by sine of Q. All these will give you the same answer. So R is 2.7 over the sine of R. So P is what you're looking for. P over the sine of P. Sine of P is 50. Angle P is 50 is equals to R is 2.7 divided by sine of R. Angle R is 65. So just make P the subject, the formula. P be given by 2.7 sine 50 divided by sine of 65 degrees. This will give 2.28 give 2.282 centimeters. So that is QR. So remember, P was QR. Angle, that is part 2. Angle PRS. PRS, you can see that angle is here. This is the angle to get. And to get that, we're going to consider triangle PRS. PRS. Consider that triangle. You are given all the sides, 6, 7, and 2.7 in that triangle. So to solve that, to get that angle, we can use the cosine rule. So I will let this side opposite R to be noted by R, side opposite S. So the side opposite S, name that as S, like that. Side opposite P, name it like that. So note these. So now, this is how we use the cosine rule. Since you're looking for angle PRS, this is how we give the cosine rule. R squared is equals to the sum of the squares of the other sides, which is P and S, P squared plus S squared minus 2P PS cosine of the angle at R. The angle at R. That is what you're looking for. So that is how you go about the cosine rule. So let's substitute these figures. So we have R. So R is 6. So that will be 6 squared minus P. P is 7. And S is 2.7 minus 2 multiplied by P multiplied by S multiplied by the cosine of angle R, like that. So working out these, 6 squared is 36 is equals to 7 squared plus 2.7 squared. That will give 56.29 minus 2 times 7 times 2.7. That will give 37.8 cosine of R. So I will take negative 37.8 cosine of R to the left hand side. So I'll take this on this side, and then I'll take 36 to the right hand side. So we'll get 37.8 cosine of R is equals to 56.29 minus 36. And this will give 37.8 cosine of R is equals to, when you subtract that, 56.29 minus 36, you get 20.29. So divide both sides by that 7.8, and that will remain with cosine of R of 20.29 divided by, that is 7.8, and this will give cosine of R to be given by, divide that 20.29 divided by that 7.8, that will give 0.5368. To get R, you need to get the cos inverse of 0.5368. Cos inverse of that, and this will give 57.54 degrees. And that is angle R, which is also angle PRS. That is the angle that you're looking for. The last question, determine the area of the circle. So let's go to that circle. To get the area of that circle, we need to get the radius. Since for us to get the area of the circle is given by pi r squared. So we don't have the radius, so we need to calculate the how do we get the radius? We get the radius from the sine rule. Already we have obtained this angle, that is here. So let me sketch this. So this is R, this is a P, this is S. So we already have this angle as 57.54. And you have this side which is 7, this is 6, and this is 2.7. So we can use the sine rule. Which is 6 divided by sine of 57.4 is equals to 2r. This is what is going to help us to get the radius. So using the sine rule. So let's go to the working. So 6 divided by sine of 57.54 degrees is equals to 2r. So 6 divided by sine of 57.54, that will give 7.111 is equals to 2r. So to get r, divide both sides by 2, and radius will be 3.555 centimeters. Now we have the radius. Area is equals to, we use pi to be 3.142 times the radius, that is 3.555 squared, and this will give 39.71 centimeters squared. So that is how we're supposed to solve that question. Question 23. The displacement x meters of a particle moving along a straight line after t seconds is given by x is equals to, let me write, this one is not clear, x is equals to t cubed divided by 3 minus 3 t squared plus 9. Part A, determine 1. The values of t when the particle is momentarily at rest. You're given displacement, that is x. You're required to get values of t when the particle is at rest. One thing you're supposed to understand is that the particle will be at rest when velocity is equals to 0. But now we don't have velocity, we have displacement. Note this: when you're given distance, you differentiate distance to get velocity. You differentiate velocity to get acceleration. So in this case, we are going to differentiate displacement, or what we call the distance. That is, velocity will be given by, we differentiate x with respect to t, that will give us velocity. And when you differentiate this function, this is what you're going to get. You'll get t squared. When you differentiate t cubed over 3, you get t squared, then minus 3t squared, you differentiate that, you get 6t. For 9, you get 0. So therefore, velocity is given by t squared minus 6t. When the particle is momentarily at rest, velocity is equals to 0. So substitute velocity is 0. So 0 is equals to t squared minus 6t. Now you're supposed to find the values of t. So t squared minus 6t, you can factor out t. T is common. So you get t minus 6 is equals to 0. So we'll get two values of t. T is equals to 0, that is 1, or t minus 6 is equals to 0. And for this case, you get t to be 6. So the values of t when the particle is momentarily at rest is therefore t is equals to 0 seconds and t is equals to 6 seconds. Part 2, the values of the displacement x meters by the time the particle comes to rest. We have already calculated the values of t when the particle comes to rest. That is, t is equals to 0 and t is equals to 6. So now we need to find the displacement at these times. So what will be the displacement when t is equals to 0? You simply take the expression for displacement, which is x. X is equals to t cubed. X is equals to t cubed over 3 minus 3t squared plus 9. Simple as that. So just substitute. So when t is equals to 0, just substitute. X will be given by, so while you have t, substitute that with 0. So you'll have 0 cubed over 3 minus 3 0 squared plus 9. So for these, x will be 9 meters. So what about when t is equals to 6? They substitute x is equals to 6 cubed, substitute, so t cubed 6 cubed divided by 3 minus 3t squared, like that, plus 9. And for these, this is a calculator, you'll get negative 27 meters. So therefore, the values of displacement x when the particle comes to rest is 27 meters and 9 meters. Part B, determine the values of t when the velocity of the particle is negative 5 meters per second. Values of t when velocity, we already have the expression for velocity. We got velocity in A part 1. Velocity is given by Trapezium. V is equals to t squared minus 6t. Now you're required to, when v is equals to negative 5 meters per second, you just need to substitute. So t squared minus 6t, which is velocity, is equals to minus 5. You're substituting v, we have v with negative 5 meters per second. So you notice that this one will form a quadratic equation. T squared minus 6t, bring negative 5 to the left hand side, you get plus 5 is equals to 0. So you simply need to solve these. So when you factorize these, you're looking for two numbers, use factorization, whose product is going to be 5 and sum will be negative 6. So these will be negative 5 and negative 1, the numbers. So you have t squared, so negative 6 written using negative 5 and negative 1 will be negative 5t negative t plus 5 is equals to 0. Factor out t, so this will be t minus 5, then minus 1, t minus 5 is equals to 0. So t minus 1 multiplied by t minus 5 is equals to 0. So therefore, t minus 1 is equals to 0, t will be 1, or when t minus 5 is equals to 0, t will be 5. So those are the values of t. So 1 second and t is equals to 5 seconds. Simple as that. Part C, determine the acceleration of the particle at t is equals to 2 seconds. So how do you get acceleration? We get it after differentiating velocity. So we have the velocity, which is given by t squared minus 6t. So acceleration will be obtained when we differentiate velocity with respect to t, which will be 2t minus 6. So acceleration therefore is equals to 2t minus 6. So now when t is equals to 2 seconds, you just need to substitute. So acceleration is equals to 2, substitute t with 2, and this one will give 4 minus 6, and this will give negative 2 meters per second squared. So that is the acceleration. That is how you're supposed to solve that question. Question 24. In this question, use a ruler and a pair of compasses only. Line PR is a diagonal of a quadrilateral PQRS. PR is equals to 6 centimeters. The line is there. Let's go to the questions. A. Locate vertex Q of the quadrilateral PQRS such that angle RPQ is equals to 60 degrees and angle PRQ is equals to 45 degrees. Complete triangle PQR and hence measure the length PQ. 4 marks. So let's begin with part A. I will not use this line. The line is not straight. It is distorted due to poor scanning. So allow me to just draw another line on a different page. There's no difference that it's going to make in the solution as long as it is a line that is PR 6 centimeters. So I've drawn the line there. So the first part you're required to, this is the question, locate vertex Q. And to do that, you're required to construct 60 degrees. Angle is 60 degrees. That is angle RPQ is equal to 60 degrees. So you're going to construct an angle of 60 degrees at P. So begin with that. So to construct 60 degrees, take your pair of compasses and stand at P. That is why you want to construct 60 degrees. So open a pair of compasses in the radius, convenient radius, then mark a big arc like that. Then with the same radius without changing anything, stand at this point where the arc cuts line PQ and cut that arc. That is how you construct 60 degrees. Then join P using a straight line from point P to the point of intersection of the arcs. So join that. Let me join this one properly. So join P, the point of intersection of the two arcs, like that, using a straight line. So that angle is 60 degrees. The other question, or the other part, you're supposed to construct this angle PRQ to be 45 degrees. So that means you're constructing an angle of 45 at R, an angle of 45 at R. So how do you construct an angle of 45 at R? So I will extend this line. So allow me to extend this line. I'll extend line PR. Let me extend it like that. And then to construct an angle of 45 at R, I'll begin by constructing an angle of 90 degrees. Then I bisect it to get 45. So let me start by constructing an angle of 90 degrees. So to construct an angle of 90 degrees at R, stand at R, then open any convenient radius. Then with that radius, mark an arc here, one arc there. Then on the other side, mark an arc. Then from there, now you can change your radius. And then stand on one of these arcs that you've made. And at that point, then I will mark big arc there with the same radius without changing it. Stand on the other arc and cut that arc. That will be 90 degrees. You can join this point here. That is 90 degrees. So that is 90 degrees. And since you require a 45, so you have 90 degrees here. So you have 90 degrees here and 90 degrees here. So the angle on the left, that is 90 degrees on the left, you can bisect that to get 45, divide it by 2. And to do that, to bisect that angle, pick your pair of compasses and then stand at R, then mark an arc in a radius, mark an arc there and another arc there. Then now you can change your radius. Once you've done that, change your radius, stand on one of the arcs that you've made and mark an arc there. Then with the same radius without changing it, stand there and cut that arc, you're bisecting it. Then from there, using a straight line, join R, the point of intersection of those arcs, like that, and you have bisected that. So now this angle is 45 degrees and this one is 45 degrees. The question, you are supposed to locate the vertex Q. So now we have Q. Look at the point of intersection of the line from P and the line from R. So Q is here. This is where we have Q. Q is that point there. So you can label that. So that is Q. And you are required to measure complete triangle PQR. We do that. Have we done that? Yes, PQR is there. And measure the length PQ. So let me get the measurement of PQ. Measurement PQ is 4.4. You can see it there. That measurement is 4.4. So you can read it here. It is here 4.4. So we've done that. So that is 4.4. So PQ, write it here. So PQ is equals to 4.4 centimeters. Let's go to part B. Diagonal QS, which is 10 centimeters long, intersects with the diagonal PR at right angle. complete the quadrilateral PQRS. QS, you don't know where S is. QS, that is diagonal, and it intersects with the diagonal PR at 90 degrees, at right angle. So what we mean simply is we are required to drop a perpendicular, a line from Q that is 10 centimeters long that will meet PR at 90 degrees. In simple terms, you're required to drop a perpendicular from Q to meet PR at 90 degrees. So how do you do that? You simply take your pair of compass and stand at Q, and then ensure that you mark two arcs. Ensure that you mark two arcs standing at Q. So standing at Q, mark two arcs on line PR. You must ensure you do that. So let me check whether I'm able to do that. So mark two arcs. So you can as well extend. If you find you are not able to mark the arcs correctly, you can always extend line PR. You can extend it like that. So with that, now I want to mark two arcs. Even if it is on the line PR extended is okay. So I'll mark the first arc here, standing at Q, one arc there, and then another arc there. Then from there, you stand on one of the arcs that you've made like that. Then you can adjust the radius, and standing on one of the arcs, you mark an arc like that. Then with the same radius without changing it, stand on the other arc there. Then cut that arc, that arc like that. So after making the arcs from Q, join Q to the point of intersection of those arcs using a straight line like that. Now this line meets PR at 90 degrees. That line should be 10 centimeters long. So to ensure I'll be measure using my pair of compass here, the line is supposed to be 10 centimeters long. Yes, 10 centimeters is there. So mark that is 10 centimeters. So therefore QS, S should be here, this point here. That one is supposed to be 10 centimeters. Now we have QS. Then from there, complete the quadrilateral PQRS. So to do that, you simply join on a straight line. So from P, join P to S, and then using a straight line, then R to S. Simple as that. Now you have the complete quadrilateral PQRS, and QS is 10 centimeters. So we are done with that. The last one is calculate the area of quadrilateral PQRS. How do we get the area? This quadrilateral is divided into two shapes, two triangles. So you can get the area of triangle PQR plus the area of triangle PRS. That will give you the answer. So let's begin by getting the area of triangle PRQ. So to get the area, I just look at that triangle. You have an angle of 60. We have PQ. We got PQ as 4.4. PQ is 4.4. And we have side PR, which is 6. So we can use this formula. So area of triangle PRQ. So we can get this one by I have AB sine theta. Where we have this one is half multiplied by A being 4.4, B being 6. Those are the sides between the given angle. Then times sine of 60 degrees. So let us work out that. So 4.4 multiplied by 6 multiplied by sine of 60. That will give 22.2. Then you divide by 2. You get 11.43. 11.43 centimeters squared. Now let us get the area of triangle PRS. For PRS, we don't have any angle, but we have the base. We can use PR as the base, which is 6. So we can use this as the base, and then the height, we use this one as the height. So we take this measurement and take that measurement. So this measurement here, we can call this point, we can mark this point as M. So this height from MS. So let me get MS, take that measurement, MS. So MS is 6.2. MS is 6.2. So this is a 6.2 centimeters. And then the base, taking the base as PR. So area of that triangle will be given by a half times the base, which is PR, which is 6, times the height, MS, which is 6.2. Working out this, we get 18.6. So this will give 18.6 centimeters squared. So now we have the areas of the area of the two triangles. Therefore, the area now of the quadrilateral PQRS will be given by area of triangle PRQ, which is 11.43 centimeters squared plus 18.6 centimeters squared. So add the two, this will give 30.03 centimeters squared. And that is how we're supposed to solve that question.